All right, this is Geometry B, Unit 6, Lesson 7. We're going to find areas and volumes of similar solids. Right? There's an overarching principle when we talk about similar solids, when we talk about dimensions like length and perimeter, and area and volume. Okay? And here's the overarching principle here. I'm going to create a little bit of a sketch, a graphic that'll hopefully illustrate the idea. Let's start with a basic cube. Okay? The basic cube has a side length of 1. It has a surface area, let's just consider the area of the front face. The area is 1 times 1, or 1 square unit. 1 unit squared. And the volume of the entire thing is 1 times 1 times 1, or 1 unit cubed. Okay? So that's a side, an area, and a volume. Okay, now let's double the dimensions here, and let's make a cube that is 2 by 2. What happens when we double the dimensions? Well, you can hopefully see that we multiply the area by 4. Okay, and if you count the volume here, the number of cubes that make it right here, so the side length is 2 units. The area now of the face is 4 square units, and the volume now is 2 times 2 times 2, or 8 cubic units, right? So when we double the dimensions, we quadruple the area, and we octuple the volume. Okay? Let's triple it. So let's triple it here. So here we go. Let's draw a cube that is 3 by 3 by 3. Okay, you can see hopefully that by multiplying the side length by 3, we multiply the area by 9. And we multiply the volume, if you can count the cubes that make this, 3 times 3 times 3, or 27. So the dimensions are 3 times what they were, and the area is 9 times what it was, 9 units squared, and the volume is 27 units squared. So we took the original and we multiplied by 3, but we multiplied the area by 9, and we multiplied the volume by 27. Okay, where do these numbers come from? Okay. And they come from this. They come from squaring and cubing, right? So 2 squared is 4. 2 cubed is 8. 3 squared is 9. 3 cubed is 27. Because 3 times 3 times 3 is 9 times 3, or 27. Okay, let's do it one more time. Let's do a 4 by 4 cube. Okay, so now I've multiplied my dimensions by 4, and you can see hopefully that we now have an area of 4 by 4, or 16, right? So the dimensions are 4 times what they were. Now the area is 16 units squared, and if you can count them, you will find that this is made up of 4 times 4 times 4, 64 cubes, little cubes, right? 4 squared is 16, 4 cubed is 64. Okay, 4 times 4 is 16, 16 times 4 is 64. Okay? And so here's the rule. Here's what the pattern is going on. If we have two similar solids with a ratio of dimensions, a ratio of A to B, then the ratio of areas is going to be A squared to B squared. And the ratio of volumes is going to be A cubed to B cubed. Okay? let me give you an example here. Molly wants to paint a canoe. Okay, and she's going to make a canoe that's a scale replica of an existing canoe. Okay, so the original canoe is 18 feet long, okay, and weighs 115 pounds. Okay, and it took 0.5 gallons of paint to paint it. Okay, but Molly's canoe is going to be smaller. Her canoe is going to be only 12 feet long. Okay, the question I'm going to ask is, what will her canoe weigh? And how many gallons of paint will she use? Okay, how many gallons of paint will she use? Now you'd think, being 12 feet long, that it's not half the length. It's about a ratio of 12 to 18, 2 to 3. So it's 2/3 the length. You would think it would weigh 2/3 the weight, and it would use 2/3 the amount of paint, but that's not correct. Okay, let's look at the ratios. The ratio of areas, or ratio of lengths, is 18 to 12. Let's reduce that by dividing by 6. That's 3 to 2. Okay, so the ratio of areas is 3 squared to 2 squared. 3 squared is 9, 2 squared is 4. So the ratio of areas is 9 to 4, and that would go to the question of how much paint she's going to use. Okay, so to answer the question about paint, I would do this. I would do 4 is to 9, small is to big, as small, and we'll call this P for paint, is to large, half a gallon, 0.5. And I would solve this proportion. Half of 4 is 2. And we would use 2/9 a gallon of paint. 2/9 or 0.22 gallons. Okay, so that's less than half the original amount of paint that she would have used. Okay, what's more is the volume, which would relate to area, or the weight. The weight would relate to volume. The volume is going to be 3 cubed to 2 cubed. 3 cubed being 27, 2 cubed being 8. So it's going to be the ratio of 27 to 8. So for the weight of the canoe, I'm going to do small to big. 8 is to 27 as the weight of the small canoe, we'll do W for weight, is to the weight of the big canoe, 115 pounds. Okay, so cross multiply and divide. 115 times 8 divided by 27. 115 times 8 divide 27, and I'm not going to try to do that in my head. Let's pull up Desmos. And here we go. 115 times 8 divide 27, 34.1 pounds. That is considerably less weight, 34.1 pounds. Okay, so we found the ratio of lengths was only 2/3, but it's not 2/3 the weight. It is about one fifth or 1/4 the weight, right about there. 34.1 pounds. So here's the big idea. Once again, if the ratio get the right side here. If the ratio of dimensions is 3 to 2, then the ratio of areas is 9 to 4, and the ratio of volumes is 27 to 8. We get that by squaring for area and cubing the ratio for volume. Okay? That's the big idea.